Hello everyone. We have a question from the modulus inequality where it says that solve it, that means finding the solution. Because it is an inequality, definitely the solution would be the set of values for the given variable, which is x. So basically the final answer would be the set of values of x. We have two methods to solve it. One is through the algebra and the other is graphical method. So let us first work on the algebraic method, and then we will work on with the graphical method. For algebra, the process is very simple. Just go for squaring both sides, and after squaring both sides, simply use the formula of a plus b whole square. And if it is negative somewhere over here, just use a minus b whole square. And we know that if it is a plus b whole square, it would be a square plus 2ab plus b square. And similarly over here, 3 square as 9, and instead of x plus 2, which is x plus 2 whole square, it is a plus b whole square. It would be a square plus 2ab plus b square. After just multiplying this 9 with this and then simplifying, 9x square is over here, 4x square, and 4 is less than 9, just moving this 4 on the other side and moving all of them on the other side and rearranging them in such a manner that the like terms are written next to each other, x square with x square, x with x, and a constant with constant. And after simplifying them, we have a proper quadratic equation because this condition was less than 0. So definitely we have written the quadratic form less than 0. The next step is to find the critical values. Critical values means the values of x which are on the x-axis, because over here it is 0, which is representing the value of y. That means we need the two values of x which are on the x-axis. That means the x-intercept, also called as the critical values. Just use the quadratic formula. Using the quadratic formula and using the values of a, b, and c, which are a is 5, b is positive 24, c is positive 27, use the values of a, b, and c, place it in the quadratic formula, simplify them, and get the two critical values. Critical values means the x-intercept. And we have minus 9 upon 5 and minus 3, and minus 9 upon 5 over here, and negative 3 is less than minus 9 upon 5 over here, because the quadratic equation has a positive coefficient. X square is positive 5. So definitely, because it is positive, we will have a U-shaped graph. Secondly, the quadratic equation is less than 0. Less than 0 means negative. Negative means a negative value of y. So basically we need all the values of x which would definitely give a negative value of y. By observing this graph, we could easily say that all the values of x which are between minus 3 and minus 9 upon 5, that means greater than minus 3 and less than minus 9 upon 5, would definitely result in a negative value of y. If we take any value less than minus 9 upon 5 over here, and if we draw a graph, we can see that yes, it is giving a negative value of y. Or if we take any value greater than negative 3 and we draw a straight line on the graph, we can observe that yes, it is giving a negative value of y. That means finally we have observed that if we have a condition where it is less than 0, that means negative, and negative means negative value of y, the solutions would be this one. So for this particular question, the set of values of x are all the values greater than negative 3, like I have written x is greater than negative 3 and less than minus 9 upon 5 over here. But just keep one thing in mind, the question that we are attempting contains a modulus on both sides of the equation. We could come across some question where we have a modulus sign on just one side and the other side will not contain a modulus. In that question, the working would be almost same till here, almost like I would say 90% working would be same, but at the end, observing the final set of values, we have to think it another way and we have to work it another way and get the set of values. So definitely we have a different method to observe the set of values if we have a modulus on both sides, and if we have a modulus on just one side of the inequality sign. We cannot treat both the condition as same. So for this particular question, if we have a modulus on both sides, the process is in front of you, very simple. We could easily work according to it, get the set of values of x, and we are done. As I said in the beginning, we can also use another method, which is a graphical method, and solve the question. So let us move on with the graphical method. Because the question contain two linear modulus equation on both side of the inequality sign, so treat them equal to y. Both the linear modulus equation, they are equal to y. Just take dummy values, negative, 0 or positive, and get the required values of y. Because they are linear equation, definitely the graph would be a straight line equation. Secondly, what we have observed is that the modulus is never negative. We know that the modulus is never negative. The modulus can have a positive value or a minimum zero value. That is why you can see when we use x as negative, 0 or positive, over here as well also we observe that the values of y were all positive, because the modulus is never negative. Similarly here, the modulus is never negative, that means it is always positive, and when multiplied by 3 would be always positive, that means the y will always be positive, and we can see through the readings. Now just draw the graph of both the given linear modulus equation, and you can see that I have used two different colors so that the observation could be made easily and we could find the set of values. But before that, just look at the graph, that the graph is a straight line, but the graph is just touching the x-axis and bouncing back. You can see both the graphs, whether it is the red line or the green line, they are not below the x-axis. Why? Because if it is below the x-axis, y would be negative, and we know that both are linear modulus equation. Definitely y would never be negative. That is why y would never be negative, and from the graph it is easily observed that y is never negative, because the y is completely above the x-axis or just touching the x-axis. Secondly, the graph is intersecting at 2 points, and the 2 points are the -3 and the same -9/5, which we got from here when we went through the process of algebra through quadratic equation. Now the next point of observation is, I have used red color and green color. This red color is for the graph of y is equals to 3 modulus x plus 2, and the green is for this one, which is modulus 2x plus 3. That means this green line is representing 2x plus 3, which is this one. This is your green, and this one is the red one. According to the question, the green one is greater than red one. When we say green one is greater than red one, what does that mean? If we just observe the graph, if we take any value less than -3, if we take any value less than -3, we can observe that the red line is above the green line. That means the red line is greater than green line. Or if we take any value greater than -9/5, it is observed that the red line is above green line. That means the red line is greater than green line. Or if we take any value in between -3 and -9/5, that means greater than -3 and less than -9/5, it is observed that the green line is above the red line. That means the green one is greater than the red one, and the green is represented by this So that means this one is representing green, 2x plus 3 is green, and green is greater than red. And if you look at the question, this is representing green, and the question is also saying the same thing, that green is greater than the other one, which is the red. That means from the question and from the graph, this is representing green, this is representing red. That means green is greater than red. Over here we can see, yes, green is greater than red because it is above red. That means finally we can say that the set of values of x are greater than minus 3, like we have written over here, and less than minus 9 upon 5. So it is totally up to you what method to use in the paper. You don't have to use both of them, you can use any one of them, but I would highly recommend go for the algebraic method. That doesn't mean this is wrong. You can use the same, it is totally up to you what method to use. Both are acceptable. You would be awarded with the complete marks if you use any method correctly.